There's something in the universe you've never seen, never touched, never directly measured, but right now it's controlling the fate of billions of galaxies. An invisible force that represents 27% of everything that exists. And what if I told you that the world's greatest scientists are in a desperate race to find this phantom substance? Because discovering what it really is could destroy everything we thought we knew about physics. Earth orbits the sun at 67,000 miles per hour. The solar system orbits the center of the Milky Way at an incredible 514,000 miles per hour. But here's the problem. When scientists calculated how much visible matter exists in our galaxy, all the stars, planets, cosmic gas, dust, they discovered something terrifying. There isn't enough mass to hold it all together. Our galaxy should have torn itself apart billions of years ago, but it didn't. In 1933, astronomer Fritz Zwicky was observing the Coma cluster when he noticed that galaxies were moving too fast for the amount of matter he could see. He calculated there should be 400 times more mass than was visible. He called it Dunkelmaterie, dark matter in German. The scientific community ignored his findings for decades, until in the 1970s, astronomer Vera Rubin proved he was right. She measured the rotation speed of stars and spiral galaxies and discovered something impossible. Stars at the outer edges rotated as fast as stars near the center. This violated everything we knew about gravity. There were only two possible explanations. Either Isaac Newton and Albert Einstein were fundamentally wrong about how gravity works, or there's a completely invisible form of matter permeating the cosmos. To understand how bizarre this is, imagine you're driving a car around a curve. The faster you go, the more centrifugal force pushes you out of the curve. To make the turn without leaving the road, you need enough tire friction. Now imagine you're taking that curve 3 times faster than should be possible, but the car simply stays on track. Something invisible is holding you there. That's exactly what's happening with galaxies. Galactic rotation curves, graphs showing star velocity versus distance from the center, should drop drastically at the outer edges, but they remain flat, constant, as if there were a massive, invisible halo of something surrounding each galaxy, providing the extra gravity needed. And that's not all. When astronomers observe massive galaxy clusters, they detect something called gravitational lensing. Light from distant galaxies is bent and distorted as it passes near these clusters, exactly as Einstein predicted. But when they calculate how much mass would be needed to cause this extreme curvature, they find the same problem. Visible mass is enough. Not even close. In some cases, the amount of gravitational lensing indicates 5 times more mass than we can see. 5 times. The most dramatic case? The Bullet Cluster. In 2006, astronomers captured images of 2 huge galaxy cluster collisions that happened 150 million years ago. When they analyzed the data, they saw something extraordinary. The hot gas in the galaxies, which we can detect via X-rays, stayed behind the collision center, but most of the mass, detected through gravitational lensing, went straight through. It passed through the collision like ghosts. This was the clearest evidence that dark matter doesn't interact with normal matter. It simply passes through everything. Through you, through Earth, through entire stars. Right now, trillions of dark matter particles are passing through your body. You feel nothing because they interact so weakly with ordinary matter that it's as if you don't exist to them. So, what exactly are scientists looking for? The most popular theory involves something called WIMPs, weakly interacting massive particles. Imagine particles that have mass, perhaps 10 to 1,000 times the mass of a proton, but rarely, very rarely, collide with normal matter. We're talking about a particle going through the entire Earth and having maybe a 1 in a trillion chance of hitting an atom. Physicists built massive detectors deep in abandoned mines, protected by kilometers of rock to block cosmic radiation. They filled enormous tanks with ultra-pure liquid xenon, cooled to temperatures near absolute zero. The idea? If a dark matter particle collides with xenon nucleus, it will produce a tiny flash of light and release some electrons. The XCNONNT experiment in Italy uses 8.3 tons of liquid xenon. LUX Zeppelin in the United States uses 10 tons. They're looking for literally 1 or 2 events per year in tons of material. The problem? Decades of searching, billions of dollars invested, zero confirmed detections, absolutely nothing. Some physicists began exploring another candidate, Macho's massive compact halo objects. These would be common but dark astronomical objects, brown dwarfs, primordial black holes, rogue planets, things made of normal matter, but invisible because they don't emit light. Microlensing campaigns scan millions of stars, looking for brief brightness amplifications when a Macho passes between us and a distant star. They found some, but not enough. Not nearly enough to explain all dark matter. Machos could contribute maybe 20% of dark matter at most. The rest? Still a total mystery. Here's where it gets really interesting. Some of the world's most respected physicists began questioning whether we're asking the wrong question. What if there's no dark matter? What if gravity simply doesn't work the way we think at galactic scales? Mordechai Milgram, an Israeli physicist, proposed something radical in 1983 called MOND, Modified Newtonian Dynamics. His idea: when gravitational acceleration becomes very, very small, like at the outer edges of galaxies, Newton's laws stop working in the traditional way. Instead of gravitational force being inversely proportional to the square of distance at extremely low accelerations, it becomes inversely proportional only to distance. A small change in the math, a gigantic impact on the results. And you know what's disturbing? MOND predicts spiral galaxy rotation curves with frightening precision, without invoking a single gram of invisible matter, just by modifying the law of gravity. But MOND has problems. It can't explain the bullet cluster. It doesn't work well for galaxy clusters. And it goes against a century of Einstein's general relativity, which has been tested with incredible precision in every other situation. So other physicists propose something even stranger. What if dark matter isn't made of discrete particles? What if it's a dark fluid, a continuous, exotic field permeating space? Some theories suggest dark matter could be a Bose-Einstein condensate on cosmic scale, a quantum state of matter where countless particles behave as a single giant entity. This would explain why it distributes in smooth halos around galaxies instead of clumping together. But the candidates don't stop there. Axions, hypothetical particles originally proposed to solve a completely different problem in particle physics, emerged as favorites. They would be trillions of times lighter than an electron, but would exist in such astronomical quantities that their collective mass could form dark matter. Detecting axions requires a completely different approach. Instead of waiting for rare collisions, physicists build resonant cavities in intense magnetic fields. If axions exist and pass through the magnetic field, a microscopic fraction of them would convert into detectable photons. It's like trying to hear a whisper at a rock concert. Sterile neutrinos are another candidate. We know normal neutrinos exist. Trillions pass through you every second from the sun. But sterile neutrinos would be heavier, even more ghostly cousins. They wouldn't interact even through the weak nuclear force. Only gravity. There's a detail few outside the scientific community know. Dark matter isn't just important for understanding galaxies. It literally created the structure of the universe. In the first 380,000 years after the Big Bang, the universe was a hot, dense soup of matter and radiation. Radiation pressure was so intense that ordinary matter couldn't clump together. It couldn't collapse under its own gravity to form the first stars. But dark matter? It doesn't interact with radiation. So while ordinary matter was being pushed around by photon pressure, dark matter was silently clumping together, forming the first gravitational structures of the cosmos. These dark matter concentrations created the gravitational wells where, eventually, after the universe cooled enough, ordinary matter could fall and begin forming stars and galaxies. Without dark matter, the universe would be completely different. Possibly no galaxies, no stars, no planets, no you. The cosmic web, that structure of gigantic filaments connecting galaxy clusters across hundreds of millions of light years, is basically a map of dark matter distribution. Galaxies are just luminous decorations hanging on this invisible scaffold. Computer simulations can reproduce the large-scale structure of the universe with incredible precision, but only when they include dark matter. Without it, Simulations produce a universe that looks nothing like what we observe. And here's something that will make you question reality. Some cosmologists calculated that if the amount of dark matter were just a few percent different, just a few percent, the universe would be radically different. Much more dark matter. And galaxies would collapse too early, forming giant black holes instead of stellar nurseries. Much less. And galaxies would never have formed. It's as if the universe were fine-tuned to allow our existence. But there's something scientists are discovering now that could change everything. And this discovery is happening in a completely unexpected place. The moon. For decades, all dark matter detection experiments were conducted on Earth. But Earth has a problem. Background radiation, cosmic rays, natural radioactivity. All of this creates noise that can look like dark matter signals. The moon has no atmosphere, no strong magnetic field. It's a naturally quiet environment for particle detection. And scientists are proposing to install dark matter detectors in permanently shadowed craters at the lunar poles, where temperatures are naturally near absolute zero. But there's more. Some theoretical physicists propose that the moon itself could have captured dark matter over billions of years. Dark matter particles that collided with atoms in the lunar interior and lost enough energy to become gravitationally trapped. Over eons, these particles could have accumulated in the lunar core. If this is true, we could detect signs of dark matter annihilation coming from the moon center. Gamma-ray flashes, exotic neutrinos, signals that would be impossible to detect from Earth, but that nearby space telescopes could capture. Missions are being planned. Proposals are being written. But here's the problem. Nobody knows for sure what they're looking for. And some scientists are starting to wonder if the silence of the detectors is trying to tell us something. Something disturbing. The LUX Zeppelin detector began operating in 2022. It's the most sensitive direct dark matter detection experiment ever built. If WIMPs exist in the mass range most physicists expect, LZ should detect them. The first results? Nothing. XCNONNT, even more sensitive, began collecting data in 2021. Initial results? Nothing. We're reaching a critical point. If these next-generation detectors find nothing in the next few years, WIMP theory, the favorite explanation for decades, will be in serious trouble. This doesn't mean dark matter doesn't exist. It means we might be looking for the wrong type of particle, or that dark matter interacts even more weakly than we imagined, so weakly that it may be fundamentally undetectable by direct methods. Some physicists are exploring indirect detection. Instead of waiting for dark matter particles to hit detectors, they look for dark matter annihilation products in space. When two dark matter particles collide, they can annihilate, producing high-energy gamma rays or exotic positrons. The Fermi Space Telescope has been looking for gamma-ray excess coming from the Milky Way center, where dark matter concentration should be highest. They found something, an anomalous signal, but it's unclear if it's dark matter or just undetected pulsars. The European Space Agency's GIA mission is mapping the positions and motions of over 1 billion stars in our galaxy with unprecedented precision. These measurements can reveal gravitational perturbations caused by dark matter clumps, anomalies in stellar orbits, patterns that betray the presence of the invisible, and there are even more exotic proposals. Some scientists want to search for dark matter in Earth's geological records. If massive dark matter particles occasionally collide with atomic nuclei, they could leave microscopic traces in ancient crystals. Billions of years old minerals could contain fossilized evidence of dark matter encounters. Others propose using networks of ultra-precise atomic clocks spread across the world. If a dark matter cloud passes through the solar system, it could create tiny space-time perturbations, causing synchronized glitches in separated clocks. Experts Part 2, 1530 to 1700 hours. Lisa Randall, theoretical physicist at Harvard, proposed there could be an entire dark sector, dark matter particles that interact with each other through dark forces, completely separate from the forces governing normal matter. There would be dark chemistry, maybe even dark atoms, a parallel, invisible universe existing in the same space as ours. This idea explains why dark matter forms disks and structures around galaxies. if dark matter particles can interact and exchange energy with each other. Even if they don't interact with normal matter, they can cool and clump in more complex ways. Some physicists went even further. What if there's life based on dark matter? Organisms formed by particles we could never see or touch. Entire civilizations existing in a dimension completely inaccessible to us? It sounds like science fiction, but mathematically, it's not impossible. David Spergel, astrophysicist at the Simons Foundation, argues we need to be open to radical possibilities. For a century, we assumed dark matter will be some variation of particles we know. But what if it's something completely outside the standard model? Something requiring entirely new physics to describe? Catherine Zurek at Caltech works on dark matter theories with hidden interactions. She proposes that dark matter particles may be charged under a force we simply don't know yet. A dark force that allows them to bind into complex structures invisible to us. But here's what really keeps cosmologists awake at night. What if dark matter and dark energy are connected? Dark energy, the mysterious force causing the universe's accelerated expansion, makes up 68% of the cosmos. Dark matter makes up 27%. Normal matter, just 5%. We're literally made of the smallest fraction of the universe, and we have no idea what the other 95% is. Some physicists propose that dark matter and dark energy may be different manifestations of the same thing, a dynamic field that behaves like matter under certain conditions and like energy in others, a chameleon-like substance changing its properties depending on the environment. If this is true, the implications are apocalyptic for our understanding of physics. It means we've been fundamentally wrong about the nature of reality. And there's yet another possibility. One that few scientists like to discuss publicly because it sounds too radical. What if there's no dark matter or modifications to gravity? What if we're seeing the effects of extra dimensions of space? String theories, the most sophisticated attempt to unify quantum physics and general relativity, predict the universe has more dimensions beyond the three spatial ones we experience. These extra dimensions are normally described as compactified, rolled up so small we can't detect them. But what if some of these extra dimensions aren't so small? What if they're galaxy-sized? Gravity could leak into these extra dimensions, making it seem weaker at large distances. But the geometry of extra dimensions could create anomalous gravitational effects at galactic scales, effects we mistakenly interpret as dark matter. This would explain why we've never detected dark matter particles. Because there are no particles, just multidimensional geometry. The problem? Testing this hypothesis requires experiments at energy scales far beyond what any particle accelerator can reach. We'd be talking about energies present only in the first trillionths of a second after the Big Bang. There's a secret the scientific community knows, but rarely discusses openly. We're running out of options. Every theory needs to make testable predictions, and every testable prediction of WIMP theory so far has failed. The detectors saw nothing. Particle accelerators produced no dark matter particles. Telescopes found no unambiguous annihilation signals. MOND explains galactic rotation curves, but fails at everything else. Axions are theoretically elegant, but extremely hard to detect. Sterile neutrinos could exist, but creating the right amount of them in the early universe requires very specific adjustments. We're at a scientific impasse. And this is leading some physicists to consider something unthinkable. Maybe we'll never know what dark matter is. Maybe it's fundamentally beyond our ability to detect or understand what the laws of physics we know. Imagine trying to explain electromagnetism to someone who can only perceive gravity. No matter how many experiments that person conducts, they would never detect electric or magnetic fields directly. They would only see strange, inexplicable gravitational effects. Maybe we're in that position regarding dark matter, detecting its gravitational effects, but fundamentally unable to access the complete phenomenology. But scientists don't give up easily. New detectors are being planned. The Darwin project aims to build a liquid xenon detector with 50 tons, 5 times larger than current experiments. If WIMPs exist, Darwin will find them, or definitively exclude large ranges of theoretical parameters. Axion experiments like ADMX are increasing their sensitivity, scanning through possible axion masses. It's a slow, methodical search, but each year excludes more possibilities. The James Webb Space Telescope is observing the first galaxies that formed in the universe. Studying how these primordial galaxies developed can reveal signatures of dark matter's nature. Different types of dark matter would leave different patterns in early structure formation. The CTA Gamma Ray Observatory, Cherenkov Telescope Array, will be 10 times more sensitive than current facilities. Section 4, final. If dark matter annihilates at galaxy centers or in dark matter clumps, CTA will see the resulting gamma rays, and there are even more ambitious projects. Some scientists propose sending dark matter detectors beyond Neptune's orbit, where sun radiation and Earth's magnetosphere effects are insignificant, an experiment in the deep silence of interstellar space. Others want to dig even deeper into Earth. Mines 3, 4, 5 miles deep, where literally nothing but neutrinos and potentially dark matter can penetrate. So where does this leave us? We live in a universe where 95% of reality is invisible, where the substance shaping galaxies passes through us as if we didn't exist, where the very laws of physics may be wrong or incomplete. Dark matter may be an exotic particle waiting to be discovered in the next experiment. It may be a fundamental field as distant from our experience as gravity is from a photon. It may be evidence of extra dimensions folded into the fabric of space-time. Or it may be something we'd never imagine. Something so fundamentally alien to our physics that it will take centuries to understand. But here's the disturbing truth. Each passing day without a detection, each experiment that comes back empty-handed, increases the probability that we're dealing with something truly exotic. Something that doesn't fit into any category we've created. The next 5 years will be critical. Darwin will come online. CTA will begin observations. Lunar missions may launch. Decades of theory will be tested. Either dark matter will be revealed, ushering in a new era in physics, or we'll face the disturbing fact that the universe holds secrets that may be permanently beyond our reach. But there's something scientists recently discovered that nobody expected. Something in the most precise measurements of the cosmic microwave background. A pattern that shouldn't be there. An anomaly suggesting that dark matter may not be uniformly distributed throughout the universe as we thought. There are regions, vast regions of the cosmos, where there seems to be much more dark matter than there should be, and other regions where there seems to be much less, as if dark matter were moving, flowing, concentrating in certain places for reasons we don't understand. Some theorists are proposing something radical. What if dark matter is dynamic? What if it's not just a passive background, but something active? Something that's doing things we can't see? What if right now, massive dark matter structures are forming, evolving, maybe even interacting in complex ways, and we simply can't see them? There would be an entire universe of phenomena happening right here, in this space, in this room, completely invisible, completely inaccessible. A phantom cosmos superimposed on ours. And if one day we discover a way to see this dark universe, what will we find there? If you felt a chill realizing that we are just a tiny fraction of everything that exists, don't keep this mystery to yourself. Subscribe to the channel and hit the bell icon because we are tracking every new discovery from the James Webb and Euclid telescopes. Leave a comment below. Do you believe dark matter is a particle we haven't seen yet? Or does our science need to be completely rewritten? And if you know someone who loves to question the nature of reality, share this video. The next cosmic secret could be revealed at any moment, and you won't want to be in the dark when it happens.